Okay, we're going to work on homework 4. So, which statistics is the best unbiased estimator for mu? X bar. As you remember in the previous homework, I was talking about it. Okay, that for a population, the average or mean we call mu, and for a sample, the best unbiased estimate, it's going to be X bar. Okay, next. Oh, let's check. All right, next question. Find the critical value Z critical necessary from to form confidence interval at the level of confidence 0.95. First of all, I'm going to place the link to the lecture so you can watch it, but at the same time I'll real quick I will explain what we are talking about. Okay, so where the tail comes, you see there is less data the further we go, right? The confidence interval, we are talking about this interval here, where main data are located. So in our case, it says confidence interval is 0.95, which means 95%. So this is 95%. Let me, 95% or 0.95. So how are we going to find out the Z critical? Z critical are those. Okay, this is negative Z critical, this is positive Z critical, because the average here, Z equal always 0 when it's bell-shaped, yes? So below goes negative numbers, the above it's going positive number, therefore this point Z critical is positive, this point Z critical is negative. So how are we going to find this Z critical is behind of this Z critical, by the way, is coming your margin of error. Error, we all know what it is. Margin of error meaning maximum of error. Okay, so this Z critical is like a gate between error and confidence interval. So let's figure it out. How many percent will make this portion of error? If confidence interval is 0.95, then for these two tails, areas for these two tails, this one and this one, it's going to be 1 minus 0.95, correct? It's going to be 0.05. But we need for one tail only, one area, either for this one or for this one. So if we divide by 2, 0.05 divided by 2, I'm getting only for one, 0.025. Now, here is the thing, because our table, Z-score table, always gonna show to the left, then if I try to find Z critical, this which will gonna be Z negative Z critical to the left. But if I try to find, let me see, take Z critical to the right, I mean positive Z critical, it's going to show the whole confidence interval and these other tail also, okay, because it shows to the left. And then we need to subtract from 1 this area. The easiest way is, because these tails, this one and this one, they are by probability, which means by area, they are equal. Then what I will do, I will take this the negative find this negative z critical based on this area 0.025. I will find z critical, and then whatever value of negative z critical I will take, I just flip the sign on positive and will be my positive z critical. Okay, so let's work on it. We need to use the score table. For that reason, I prepared here the previous homework. It's a question number 11 where they have this table. 0 point, because I'm going to take negative z-score, right? So 0.025, I believe, yes? 0.025. And I'm going to find, now, what is interesting, let me explain. So, I have this area, I'm working with this area, right? 0.025 to find negative z-score, correct? So how I'm going to find, till now we learned based on z-score, right? We would pick some the whole number and first decimal, and then 0.0 second decimal, and intersection will give me probability. Now we're going to do the opposite. My probability is given, which is 0.025, and that is 2.5%. So I need to find the probability first in the body of the table. And you can, from there, you can find the z-score. Now, all this, it's under homework, previous homework 3, underneath. You will find the video for this z-score also, based on probability. Now, let me explain. So I'm going to find wherever is 0.025, let's say I found here. Then I'm coming here and here. Let's assume this gets negative 1.9. Here I'm getting 0.06. So I put together and will be negative 1.96. But z critical we use only positive. We are taking with positive sign. Okay? This is how we're going to work. One very important thing. This 0.025 or any probability that is given, not always going to be precise. So we have to find the closest one and then round up or approximate. Well, let's see what we can do. 0.025, I'm opening this table. So let me open 0.025. This is 7, 3, 4, okay, 0.0, there is only 1 0, right? Let me confirm because it's, yes, only 1 0, okay. So 0.025, here it is, 0.025, this is on, let me see, negative 1.9, and when I'm going up, it's 0.06. So the number, this score, I put it there, it was correct. Negative 1.96, and that will be 0.0, here is it, see? I'm zooming so you can see well, 0.025. So if I come by this blue shaded frame, I'm coming to negative 1.9. And from 0.025, if I go up, I'm hitting here 0.06. So it's going to be negative 1.96. So I'm going to place it here. 1, let me see, point, oops. Let me clean this also. 1.96. Let's check. Well done. Moving to next question. Another one like this. Let's see, 0.85. Okay, let's work out. So 0, my confidence interval is 0.85, which means for these both tails, it's going to be 1 minus 0.85 is going to be 0.5 and 1. Yeah, 15. I was thinking some reason light bulb. Okay, so 0.15. From here, we are going to divide by 2, obviously, right? To get for one tail, and it's going to be 0.1 divided by 2 is 0, and 15 divided by 2 is 7. Remainder is 1, and 10 divided by 2 is 5. So I need to find what z-score is matching to 0.075. Okay? I'm going to this probability, 0.075. I'm going to look in negative z-score, 0.07. Let me see where it is. Oh, here it is. 0.0745. See that? 0.0745. So it's a white frame. I'm coming horizontally. It's going to be negative 1.4. And then I'm going up 0.04. So negative 1.44. Okay. And again, I highly recommend to watch the video, and I will place the link again under this video also. So it's going to be 1.44. In previous homework, we were finding z-score based on probability, which is this decimal notation. Here we are finding opposite version. Probability is given. We are finding z-score. What is next we have? So use the value on the number line to find the sampling error. Okay, what does that mean? That means our sampling error is 3.6, right? Here it is, 3.6. But turned out the true error is 4 point, error of population, 4.57. So how we are going to find the difference? So we are going to take the difference is going to be x bar minus mu, which is equal 3.6 minus 4.57. 3.6 minus 4.57. Okay, if I subtract, it's gonna be negative 0.97, and this is gonna be error. So where is negative sign here? Negative 0.97. Now this is difference. We can easily take this negative sign, but in a case just to make sure we understood, z critical we always use positive. Okay? Well done. Next question, number 5. What do we have here? Use confidence interval to find the margin of error and sample mean. So let me explain. We need to find margin of error. So our confidence interval is 0.402, 0.402, and 0.560. 0.560. What this number mean? What means this confidence interval? Remember, in the previous problem, I was talking that this is confidence interval, right? So what does that mean? That means this between this number, it's a confidence interval, okay? Now we need to find margin of error. To find margin of error, what I'm going to do, I'm going to take the highest value 0.560 minus the lowest value 0.402 and divide by 2. Okay, so margin of error. So 0.56 minus 0.402, it's going to be 0.158. And if we divide by 2, we are getting 0.079. Okay, let's see if we need to round up or something. 0. No, it doesn't say anything. 0. And we put the fullest value. 0.079. Good job. Now sample mean. To find sample mean, what we are going to do, I'm going to take this either smallest at the lowest border, 0.402, add this margin of error, which is going to be 0.079, okay? Or subtract from 0.56 minus margin of error, and that will give me the sample mean. So I'm adding to the lowest level. It is gonna be, let me see, 9 plus 2 is 11, 7 and 1, 8, here is 4, 0.481 is going to be our sample mean, 0.481. So 0.481. Excellent. Moving to question number 6, and we need to find here minimum sample size. Okay, we need to find minimum sample size. What we are given? Confidence interval 0.98. Let me write down. Confidence interval 0.98. Sigma, that's a standard deviation of the population, 6.2. And lastly, E, it's a margin of error that is equal 1. So we need to find sample size minimum. So for that reason, we are going to use the formula sample size n is equal z critical sigma divided by error and all this squared. So we have error, we have sigma, but we don't have the critical. But at least we have confidence interval. So based on confidence interval, we can find our z critical, correct? Okay? So, well, let's see how we're gonna figure this out. So confidence interval 0.98, which means 1 minus, let me use blue color, 1 minus 0.98, it's going to be 0.02, correct? And then dividing by 2, I'm getting For one tail, I'm getting 0.01. Now I have to go and find the z-score. There was 10, right? I always get 0.01. Okay, 10 only after decimal. So 0.0, I see here, look, between these two numbers, see here, 0.0099 and 0.102. So that will give us, I would say even 0.0099. If I round up, I get 0.01. I don't even need to go there. So it is going to be, let me see, 0.0099. It's negative 2.3. And if I go up, it's going to be 0.03. So result is negative 2.33. Okay, negative, which is z critical, is equal 2.33. The rest I'm going to plug all this information. Sample minimum is equal 2.33 times sigma, which is 6.2, divided by error, which is 1, and with squaring. Okay, to go fast, let me take calculator. 233 times 6.2, okay, 14.4. Well, I know how much is 14 squared, but 156, but here I have 14.446. Let me square it, okay, and I get 208.66, 208.686, which is approximately 209. Okay, let's see. Fantastic. Okay, what is next question? Moving to scatterplot. Okay, we are going to match the scatterplot. Scatterplot, it's a form of graph that used a lot in psychology. Let's say a relationship based on graph or survey, you build this graph and you figure out if there is a firm relationship or, for example, lousy or negative going down. Okay. So, perfect positive linear correlation. Perfect positive linear, I'm looking on these blue rectangles. So first one, perfect positive linear correlation. This one, I don't know if I can, it's coming, very good. Let me see. Can I bring? It's on iPad, kind of doesn't work well. Okay, it doesn't come here. But just so you know, they already understood. It's moving further down. I'm going to do it. Okay. Is it coming here? No. Well, I have to go back again. This, if I click on this, it's not coming. Okay, whatever. You already know that this straight line is gonna be our perfect positive um, linear um, graph, and that's a perfect linear correlation. Next, strong positive linear correlation. Which one is going to be a strong positive linear correlation? We don't have strong positive linear correlation. I'll explain you why. Because if a perfect the linear correlation is going to be this, right? Like straight line. Then the strong linear correlation, it's going to be something like this. Some residues, but it's still going up. See, if I provide straight line in between, it still will be strong, strong positive linear correlation. The difference between them is this is ideal, perfect, and this one has some errors also here. Okay, so we don't have in this case strong ones, a strong positive linear correlation, and we don't have perfect negative linear correlation, because perfect linear correlation would be like this. I mean, let me see. I made that like that. Okay, so we don't have perfect negative linear correlation. What else do we have here? Strong negative linear correlation. This one we have. It's gonna be third one. If I count it, we have four graphs, right? Third one, because if you provide imaginary line, it's gonna go down, right? So the third one, it's gonna be strong negative linear, and no linear correlation. It's gonna be this chaotic one. This chaotic graph is gonna be no linear the correlation, no linear correlation. Also, the first one also no linear correlation, because it's a parabola, right? So first one and fourth one representing no linear correlation. Second one is a perfect position, a positive linear correlation, and the third one is strong negative linear correlation. Okay, moving to question number 8. Let's figure it out. We are going to again match up what we have. So the scatter plot below shows the result of a survey of 20 randomly selected males aged 24, 36, 24, 35. Using age as an explanatory variable, match each graph with appropriate description. Okay, so age and body temperature. Well, here we have the first one. Age and body temperature. That's very first one is gonna be, I'm going to try and mess up again. No, okay, I give up. Oh, that worked. Amazing. Okay. Next, age and balance on student loan. Age and balance. So where is balance on a student's loan? There has to be 4 of them. Let me see. I see here only 3, unless, one I brought already here, that's true. So age and balance on student's loan. The higher your age is, it's going to be this graph, a strong negative strong negative correlation, because the higher your age is, the less amount the loan you can get. There we go. This one looks like working, this one. Okay, what do we have next one? Age and income. Now this is gonna be a positive correlation, right? Strong positive correlation, because as you are aging, you are gaining experience, right? And it's gonna be strong positive correlation. It's gonna be this one. Let me see. Here we go. So as you are growing your experience, right? And it's going to become the direct proportional, which is strong correlation. And age and height, as you age, your height is going down. And that is simple true. So, and we have this one. So, and this, based on this graph, it can see it's not everybody is by height is shrinking. Some of them stay tall. So it's going to be chaotic in this graph. Click on it. Let me see if I can bring it down here. Bingo. Okay. Can we check it? I can't believe it. We made it on this iPad. Next. So, what is residual? So, a residual is the difference between the two observed values, y value of a data point and the predicted y value on a regression line for the x coordinate of the data point. Let me see. Excuse me. Let me see which one it is. A residual is positive when the point is above the line, and negative when the point is below line, and 0 when observed. This is last one. Let me explain. So this is our graph. Oops. This is our correlation, let's say. So what is it talking about? A residual is positive if it's above. Residual is negative if it's down. Okay? Why? Because if this is our residual, y, okay, and this is positive, so you are checking between this y and this point. So since it's above, it's going to be positive, right? This piece. Now, since this residual is negative, below, it's going to be negative. Why? Because if I take this y and subtract this one, obviously this point is smaller than this one, you are going to get negative. It's residual. Okay? That is the explanation. So, and this is going to be this one. A residual is positive, D. I'm choosing D. When the point above the line, and negative when it's below the line, and 0 when it's on the line, because it's nothing to subtract from. It's the same point, right? Let's check it. Good job. Number 10. Two variables have positive linear correlation. Is the slope of regression line is positive or negative? So positive linear correlation, that slope is always positive, right? The slope is positive. We have two cases. Slope is positive. Which one it is? As independent variable increases, the dependent variable is increases also, correct? Positive. Because, look here. Let's take this one. Positive. As independent variable, this one is increasing. This piece is have this y dependent one. X is independent, y is always dependent. So if my x is this big, my y is this much. Now my x is greater, my y is also getting greater. My x is even bigger, my y is also even bigger. Okay, we're good. Next. Well done. Moving to next one, 11. In order to predict y value using the equation of regression line, what must be true about correlation coefficient? Correlation has coefficient y. Based on that coefficient, we can figure out how strong it is. If it's 0, let me explain this real quick. Okay, this is correlation coefficient. No correlation 0. The perfect correlation is 1. And so 50-50, 0.5. So this, the lower of 0.5, it's getting weaker, and weaker. The greater than 0.5, it's getting stronger and stronger and stronger based on correlation coefficient. So if we don't have visually our graph, scatter plot graph in front of us based on correlation coefficient, we can figure it out. So what does it say? In order to predict y values using equation of regression line, what must be the true correlation? It has to be, the correlation between variables has to be significant. This one. Okay, if correlation is very low, 0.05, right? Then it's not significant. Nice work. Moving to next question. Now here we need to match up the data. Drag each symbol given to corresponding description below. Okay. The y value of data point corresponding to x is going to be yi, this one. Next, the y value for the point on the regression line corresponding to point on the regression line. It's not as a data, but point on the regression line. It's going to be y hat, this one. Slope, that's easy from algebra. Y-intercept, that's going to be b. Remember, mx plus b. The mean of the y value is going to be y bar. And the point of regression, the line always passes through x bar, y bar. Point of regression, just like on the graph, linear graph, you take any point, it's going to have x and y. But because if it's asking for average, so it's going to be x bar, y bar. Okay? Checking. Good job. Next one. Question number 12. Okay, we have it. Wait a minute, is there anything wrong? Did I miss anything? Okay, it says try again. I'll go try again. Okay, one more time. So, the value of data point corresponding for x is going to be yi. This one. Next, y value for the point of regression line is going to be y hat. Slope is going to be m. Y-intercept is going to be b. Mean y bar. And the last one, point of regression, it's by coordinate. Fantastic. Okay. Moving to question number 13. Oh, there is no question number 13. We are done. 12 questions. Well, okie dokie. Then I hope this will help you to do your homework. All right.